Okay, so I thought it's time I did a little update on what's going on with the project at the moment. I've been optimizing the coupling, and I'm actually sending in 33 volts on the high side, and it's been pulsed at actually I turned my oscilloscope up again. I suppose I better put it back on. I'll let that warm up a minute. The low side, before it stepped up, is at 16 volts as usual, 200 milliamps. That's with the load voltage that I'm going into at the moment is 7.46 volts, and we're actually seeing 30 milliamps on the input of that end. Now, when I short the output of the coils, if I short this output here, my input current, which is on the high side, will drop. You'll see how much it will drop by. Actually, let me back this out a bit so you can see everything. Right, so if I get my arm out of the way, if I short the the output, damn it. Get this knife the right way around. Right, you can see what the input current drops to 20 milliamps. That's with the output shorted. So we're actually seeing 20 milliamps on the high side. And if I look across the room, it's dropped to 100 and it's hard to see, 120 milliamps. But remember, this box uses about 50 to 60 milliamps even when it's not doing anything. So yeah, definitely seeing some improvement. This is the current that's actually currently going out to the supercapacitors. It's actually on, I suppose I better put it on the digital meter. Let's switch the digital meter to 500 milliamp range. 400 milliamp range, sorry. Let's plug this into common. I'll see a better reading on here then. The actual current going up to supercapacitors is about 60. It's actually higher than 60, 61. Weird things happen with this thing because when you start to demand current from it, the current starts to climb, which is really weird because normally when you start to demand current, the current starts to drop. So it's actually going up. This is real time, obviously. So this is the amount of current that's going up to the supercapacitors that are up there, and that unit up there uses quite a bit of, well, the LEDs use power. There's a what you call it, solar or MPPT, maximum peak transfer module up there, which is what's used for the solar. That's that little thing at the bottom with the LED on it, and that's using power. So we're not seeing as much current on the meter because that thing is using power. The actual module is using power, so we're only seeing 30 milliamp. Oh, it's actually gone up to 60 milliamp just then. Do you see that? It just went up to 60 milliamps just then. Yeah, it just kind of glitched a little bit. Anyway, I thought, oh, by the way, I got my phone sorted. Guess what it was? Guess why my... Sorry about the focus. Guess why why my phone SIM stopped working. It said no service, and I was asking for someone to help me with it, and I couldn't figure out what was wrong. And after I replaced the battery in my phone, yes, we've got a brand new battery in the phone, which is a lot better because it means that it's not going to die on me suddenly like it was. The battery I took out on my phone is in is in this box. I actually put it in the box that the new one came in. Oh, let me just open it. I'll show you what. It was a bit puffed up when I took it out. Just trying to get it out. This is the battery I took out of the phone. And it doesn't look like it now, but it was, when I took it out, it was a little bit puffed up. Man, it was hot. It was, that's the sticky side. And yeah, this battery was completely shot. It wasn't holding a charge. And it was getting very hot when I was video streaming. Which is a sign that the battery had it, basically, because when they start to they go a high impedance, you see, and with age, high impedance means they produce more heat. So look at that now. We're actually producing 75 milliamps, 77, 70. It's going up. It's 80 milliamps. Look at this shit. It's weird. This generator does some really weird things. I'm still at what, 50 milliamps still on the input side. Look at that, it's still going up. 82 milliamps. Oh, actually, part of the reason is for that is that I'm charging these supercapacitors down here, right? These supercapacitors are on the input side of this meter, right? So when these get charged up, we start to see more current on the output side, which is where it's going up to that unit up there. So up there it's just 40 milliamps right now. Yeah, we see some strange things going on, but we're pulling out 40 milliamps, and I've put my other meter on. We're going into, well, about 10 volts on the high, on the low. Well, there's a voltage drop across this wire that goes, this little wire, which is a tiny thin bit of coax. It's very thin stuff. It goes all the way up. All the way up. I'm not on about the yellow wire. I'm on about, it goes up here, up to this black wire, all the way around the back of the speaker, all the way up here to this supercapacitor thing. So I lose about 2 volts across that long piece of wire. I really need some thicker wire to reduce the drop, but we're currently sending 74 milliamps up to that battery pack stuff up there. 10.23 volts on the I'm getting reflections off everything. That's better. There's no reflection now. Anyway, while I had the phone apart, I decided to clean up I use a cotton bud to clean the lens, the inside lens of the phone. You know, where there's the autofocus lens is behind. I cleaned all that with some isopropyl alcohol. I cleaned the phone internally of the areas which looked a bit dusty. It had a good service and it's all working great now. So yeah, yeah, the thing about this, as I said, I changed these corners. I reprinted these corners because I wasn't getting enough coupling between the actual laminations and the actual core transformers in here. But at some point, as I said, I'm going to wind new coils for this, the actuator coils. I ordered some micro switches, you know, magnetic, or what do you call them? Oh, God, I can't think of the name now. You know, the little tiny reed switches, that's it, the reed switches. I've ordered some of those and they arrived today, and I'm going to use my counter to count the turns when I use my coil winder, which I designed. So what I'm going to do is I'm going to hook my counter to this manual coil winder. Then I can count the turns a lot easier instead of using the reel to reel, because that's for speed winding. So instead of having to move the read sensor, which is actually inside the reel-to-reel, which is a pain to get it out. I thought, well, it'd be cheaper and easier if I just get another reed switch and mount a magnet on this rotary. I could probably do it on that end. Put a magnet on there. Then when I'm winding new coils on here, I'll be able to count the turns without losing count, because manually doing it and losing count is a real drag, especially when you don't want to unwind it all and start again. So I keep forgetting things, so that's the reason why I didn't bother counting turns on this thing before. So I'm going to be hooking my coils up on my little bobbins for the new coils, which are over here. I'm letting them dry out because I've just acetone treated them. So I'm going to be using these little tiny bobbins to wind the new coils on. And then I'm going to put them on here. Probably going to wind two at once because they're quite narrow. I'll have to make some space to go in between, so I'll put two on there. I'll wind one and then I'll wind another sequentially, you know, because this is a bit too wide. These bobbins are very thin, they're quite narrow, so they're going to be a lot thinner coils. So I'm going to have to wind two at a time. Well, not both at the same time, but I'm going to have to wind one, then switch over and wind the other one, you know. But I'm going to have two populated in there, because this mounting assembly is for thicker coils, really. And, oh, damn, I dropped the damn thing now. So anyway, just a little update. What else is there to tell you about? I don't know. I think that's it, really. Oh yeah, the waveform. The drive pulse is the blue trace right now, and the pulse width is, well, the frequency I'm using is about 2.5 kilohertz. That's the frequency, and the pulse width of the actual width of the waveform is 400 microseconds. But that is smoothed out by the fact that it's going into 1 microfarad capacitors on the input side. So I've actually got these two capacitors across the pulse that's coming in. There's 2 times 770 nanofarad capacitors. So yeah, two times 770 nanofarad. I found out that was the ideal optimum frequency for these coils that are in there at the moment on the actuator, not these, not the output. These are output, the actuator coils down there. So I found out, but when I get the new coils wound, because these 1, 2, 3, 4 are not all the same. They were wound for a different project, you know. They were actually wound for this thing here, this generator here, rotary assembly. Because of that, they weren't matched. That's why I need to wind a new set of matched coils where they're all 4 are exactly the same. Because if all 4 are exactly the same, then I should be able to get an even better peak dip on the input, which means that my input current should be even less than what it is now, because at the moment I've got a mismatch situation where I'm trying to tune it, where one set of coils might be tuned, the other set aren't, and when I tune it so these two are tuned and these aren't, that's why I can only get it down to 50 milliamps on the input, because there's a mismatch situation going on. But the new coils that I'm winding are going to be all exactly the same, which means I should get a much better optimum peak. Anyway, so the output current is at 71 milliamps at the moment. We're only drawing 50 milliamps on the high side. Yeah, so just a little update on what's going on right now. I haven't been doing much else lately. I've been too busy with with phone fixing, and generally I've been chilling out a little bit. But yeah, so I thought I'd better do this update because it's been a few days since I did a video on this. Anyway, hope you enjoyed watching. Oh yeah, I had to go back to the Ubuntu to get this live stream to work, because unless I go to Ubuntu and click on go live, it doesn't, yeah, it doesn't seem to want to go live from the phone still. Even after I reset my phone, it won't do it. If I go directly to YouTube and go live, it seems to make it an unlisted video, and it doesn't. I don't think it's telling anybody that I'm live. That's why I decided to use Ubuntu to do that. Yeah, it's just so many things are not working right with YouTube at the moment. And they said it's better. Well, everyone's saying it's better. Well, it's not better. It's worse. Everything seems to be going downhill lately. Things are not as easy as they used to be. Anything else? Trying to think of anything else I need to update you on. Can't think of anything else at the moment. I think I've covered everything. Oh yeah, I've run out of filament, so my 3D printer filament, I run out. I ordered some more. Should be probably next week when I get that. That's all I've got left on the spool. That's all there is. So I can't print any more bobbins or anything until that arrives, which I don't really need anything else printing, to be honest, at the moment. So I've got my printed those things out I just showed you across the room, those little bobbins. So I've got them to wind, so it's going to keep me busy for another few days. Yeah, and the weird thing is, when I take these capacitors off, these are in parallel, right? These capacitors are in parallel. Yeah, there is something else to tell you. They're in parallel with the input. The purple wire and the yellow wire are coming directly from my signal, my H bridge, which is generating the pulses which you saw on the oscilloscope. These two wires are directly across the capacitors. What happens if I disconnect one of these capacitors? What happens to the input current? Watch that 50 milliamp over there. I'm trying to get it on. Are you watching? Watch what happens to that current when I take these capacitors off. 100 milliamps. Shot up to 100 milliamps. Look at that. And my output current, look, it's dropping like a stone. Right, put that back on. Back down to 50 milliamps. That's what happens with all these capacitors. If they're not on, if they're not tuned right, you lose everything. What a difference those make, I tell you. Same goes for the capacitors that are across the output coils, because I've got capacitors across the output coils. Now, if I disconnect those, the output turns back into a pulse, and it's less of an RMS waveform. If it's not RMS, then you don't get the full benefit of the output, because the bridge rectifiers can't process high speed switching very well. The bridge rectifiers are still on my old generator, but I've just bridged these wires across to it, because I thought, well, why move this bridge rectifier, which has got six full wave rectifiers on it. If I was to move all this lot and stick it on here, I've got more mess to deal with. I thought I'm just going to leave it over there and just jumper wire everything across. It's like jumping another car with a battery, you know. I'm just basically wiring to it. Thought I'll just do it that way, then I don't have to clutter my thing up with a lot of wires all feeding back onto it, and it makes it easy when I want to take this apart. I don't have to take everything apart. I can just take the jumper wires off. Saves me a lot of messing about. Yeah, I think I've got. Oh, the other thing I wanted to explain is, well, how is this working? How does this actually work? Why is it when I take the capacitors off, the current on the input suddenly goes way, skyrockets and goes way up? Well, that's because of the timing of the pulses. The pulses are coming in. Let me just try and get a pad and try and draw something on here so you can explain. There's always a bit more to tell you. I just couldn't think what it was earlier. I'll just get my pen. I'm trying to be quick because My phone's getting quite hot again. I'm down to 80% on the battery as well. Right. So the timing of the pulses, right? Let's just go to a sine wave. It's so easier to understand when we're drawing a sine wave. Right. So we have the pulse, which is right at the very start of a sine, right? So we have the pulse. I'm just going to draw it underneath. So we have our pulse, which is that tiny 400 microsecond pulse we saw. We have a capacitor, which is, I'm not going to connect it to anything, I'm just going to put the capacitor there, right? The capacitor stores that pulse, right? This capacitor then carries this waveform forward, and as it starts to, as we start to see our fall time, what's happening is that power from these actuator magnets on here is being sent back into this capacitor. So we're seeing a reverse pulse going back into this capacitor, which is assisting on the next cycle, on the negative cycle. So it's actually sending reverse pulse into the capacitor at some point during here, which is kind of linear. So it's assisting, the resonance effect on this lower, on the down cycle, on the low side. So that helps on the next, when the pulse arrives for the down cycle on here. I'll just draw it up here. So our next pulse comes in here, and this capacitor has already been biased in the opposite direction. So this, by the back EMF, it's not back EMF as such. It's not a pulse, a high voltage spike or anything like that. Although we would see it on the oscilloscope, but whatever's going on, you can't see it. It's not visible to the naked eye. It's some kind of counter-reactive force which is taking place, which is charging that capacitor to assist on the next cycle. That's why when I take the capacitor out, the current input just shoots way up. You know, it goes out off the scale, it goes up to 100 milliamps instead of 50. So we're actually getting some kind of assistive thing going on. I've been trying to see it on the scope, but it just doesn't show up. I mean, this is the driver. The blue is the driver, so you're not going to see anything on there anyway. But on the yellow, 50 volts. So if I can turn it right, oh, I want to be on 50 volt range, right? Oh, I better go a bit higher. Oh, that should be all right. I've lost my track now. The reason why is I'm going to put the probe, find the blue probe, which is down here, hooked onto my, oh, actually let's do the yellow one, because it's easier. Let me just go back on, hang on a minute, sorry about this, put that back on 10. Let's use the yellow one. Let's put the yellow one on the actual output. The yellow is currently on the, sorry, on the input, sorry. Let's unclip this if I can. I'm on the yellow probe. So that was on the output. Now let's clip it onto, oh, wires are falling off now. Ah, made me jump. I'll shorted some of that. Just a minute. Ah, where's that wire come off? Want to be on there. Right. Oh, the capacitor's come off there now. Just a minute. Oh, I wish some get off. I want that back on there. Oh, that's the supercapacitors. I've disconnected them now. This red wire's in the way. Just right, that's got connected back up. I don't want to change anything, you see. That's going back up again. Right, the probe. Oh, I see what happened. I pulled the wire off because this probe was going through that. Let me just try and get this Hang on a minute, I don't want this shorting out anything. I'll clip it on there a minute. Sorry about this. Right, I want to clip this onto the input pulse, the high side. So I'm going to clip this onto the high side, which is coming in. Oh shit, I've shorted it out. I want to be on the... Maybe I can't do that because I've got a ground somewhere else. Let me just see. No, I can't connect onto that because it's shorting it out. Let me see, why is that? Have I got the other end? Oh, I've got the other end grounded, that's why. Let's unclip the ground on the other one. I had the ground on the other end. Right, let's clip this on because the H bridge is switching ground and positive around. Let's clip onto here. Let's see if we can see anything. Right, so the yellow channel, I've got trigger lock now. I need to switch the trigger to the channel 1. Right, we can see the waveform on the input now, and we have 68 volt peak to peak on the input coils coming in. 2.5 kilohertz, which is the frequency. Now these little steps on the waveform are basically caused by those capacitors that are across the signal. So those little steps are what I was trying to explain about the inverse pulse that's counterbalancing the waveform. Anyway, you can see it on there, but my blue channel is no longer grounded, and interestingly, wrong one. I'm seeing this weird little pulse there, but that's probably because it's not grounded. I can't ground it because it'll short everything out, which is what happened before. Anyway, that's what we're seeing on the waveform. It's interesting how that's behaving. I'll have to take this off here because this is the high voltage input side, and I prefer to be measuring the output really. Let's go back to our output. Clip that back on there somewhere. Right, we're back on one of the output coils. Sorry if I can't point the phone very well when I'm looking at what I'm doing. I need to ground this one again now. Right, okay, I've got the trigger on the wrong end now. Right, I'm going to switch my trigger back to blue channel anyway. There we go. Okay. I'll put this on the 5 volt range. I'll just get a better waveform. Right, so the blue channel is on the 5 volt range, and the yellow channel is on the 20 volt range, and the yellow channel is our output on one coil, because there's actually 4 coils I'm connected to right now going into the rectifier. This one, not that one, this one, and then the one next to it. So 2 of these bridge rectifiers are not connected to anything. They're connected to this other generator, but this thing's not running, so it's not doing anything. Oh, right. I think I covered everything. Our output current is going back up again, 62 milliamps. The output voltage has gone up to 11 volts. Yeah. I'm out of breath now. So, I'm going to end the stream. How long have I been going now? Can't tell. According to the computer, it didn't even tell me on the computer. I'm looking at the computer over there and it didn't tell me. Oh well. Anyway, that's it for now. So when I get them new coils wound, which is the next step, I'll put them in and we'll do a new test. I will have to retune everything and we'll see where we go from there. Thank you for watching.